Welcome to today's ArXiv CS Digest for April 16th, 2026. We received 696 new computer science papers today across 54 subfields. Let's dive into the top picks. Trend 1 of 5, LLM/VLM Understanding and Limitations. This trend investigates how LLMs and VLMs process information, their inherent biases, and the boundaries of their comprehension and reasoning capabilities. This cluster covers 133 papers. Representative work includes generalization in LLM problem solving, the case of the shortest path, diagnosing LLM judge reliability, conformal prediction sets and transitivity violations, and how do LLMs and VLMs understand viewpoint rotation without vision, an interpretability study. Trend 2 of 5, advanced model generation and optimization. These papers explore novel methods for generating and refining AI models, focusing on efficiency, performance, and adaptability. This cluster covers 114 papers. Representative work includes leap-align, post-training flow matching models at any generation step by building two-step trajectories, web agent, a hierarchical multimodal web agent for web page generation, and stability and generalization in loop transformers. Trend 3 of 5. Multimodal visual and motion synthesis. These papers advance the generation and control of visual content and dynamic motion by integrating diverse data modalities. This cluster covers 149 papers. Representative work includes bidirectional cross-modal prompting for event frame asymmetric stereo, token light, precise lighting control in images using attribute tokens, and CRoboV2, dynamics-aware motion generation with depth-fused distance fields for high-def robots. Trend 4 of 5, foundational coding and quantum theory. Bridging theoretical computer science and quantum mechanics with practical applications in coding, optimization, and interpretability. This cluster covers 164 papers. Representative work includes heuristic search for minimum distance upper bound witnesses in quantum APMLDPC codes toward an optimal bound for the interleaving distance on mapper graphs, and superconstant weight Dix states in constant depth without fanout. Trend 5 of 5, applied AI and system evaluation. This trend focuses on evaluating and applying AI systems, particularly in complex, real-world scenarios and safety-critical domains. This cluster covers 136 papers. Representative work includes RAD2, scaling reinforcement learning in a generator discriminator framework, a manual bar-by-bar tempo measurement protocol for polyphonic chamber music recordings, design, validation, and application to Beethoven's piano and cello sonatas, and Coevolution, benchmarking cooperation-sustaining mechanisms and LLM agents in social dilemmas. Up next, our first paper out of 5, Constrained Decoding for Safe Robot Navigation Foundation Models by Aparv Kapoor and Unsuk Kong from Carnegie Mellon University. Let's break down its key contributions. Introduces SafeDec, a novel constrained decoding framework designed for autoregressive robot foundation models. It addresses the critical gap of explicit behavioral correctness by enforcing invariant safety specifications on generated action trajectories. Utilizes signal temporal logic, STL, formulas to formally express task-specific safety rules. This provides a robust and verifiable method for defining invariant safety requirements that the robot's actions must satisfy during execution. Enforces defined STL safety specifications directly at inference time on candidate action sequences. This mechanism ensures generated actions provably satisfy safety rules under assumed dynamics, providing guaranteed safe behavior without policy retraining. SafeDec operates independently of the underlying robot policy's architecture or training. This policy-agnostic approach allows for broad applicability across diverse state-of-the-art generalist policies, enhancing safety without requiring model modifications. Up next, our second paper out of 5. Does RL expand the capability boundary of LLM agents? A pass at KT. Analysis by Ziyuan Zhai and Xian Wang from Fudan University. Let's break down its key contributions. Introduces a novel two-dimensional evaluation metric, pass at KT, that jointly considers sampling budget K and interaction depth T. This metric cleanly separates capability expansion from efficiency improvements in LLM agents. evaluates LLM agents on tasks requiring tool use and compositional strategies over multiple interaction rounds. This setting is crucial for understanding RL's impact beyond static reasoning. Demonstrates that RL genuinely enlarges the capability boundary for agentic tool use, unlike in static reasoning tasks. The RL agent's performance curve surpasses the base models as K increases. Analyzes the mechanism by which RL expands capabilities, showing it reweights the strategy distribution towards better information integration. This improvement is concentrated on reasoning with retrieved information. Up next, our third paper out of 5, Tight Bounds for Learning Polyhedra with a Margin by Shamal Patel and Santosh S. Vempala from Columbia University. Let's break down its key contributions. Develops a novel pack learning algorithm for intersections of K half-spaces with a row margin. This algorithm achieves improved time complexity, significantly advancing the state-of-the-art in this area. Extends the core learning algorithm to handle a more general setting where points are only guaranteed to be at least row distance from the boundary. This broadens applicability to continuous distributions. Provides a tight complexity analysis for the proposed algorithm, demonstrating its dependence on K, epsilon, and rho. This analysis matches known lower bounds, validating the algorithm's efficiency. Up next, our fourth paper out of 5, Geometric Metrics for Most Specialization. From Fisher Information to Early Failure Detection by Dongxin Guo and Xu-Ming Yu from the University of Hong Kong. Let's break down its key contributions. Develop an information geometric framework to rigorously characterize most specialization dynamics. This framework leverages the Fisher information metric on the probability simplex for formal analysis. Prove that standard heuristic metrics violate parameterization invariance. This establishes a theoretical limitation of existing methods for measuring most specialization. Establish that expert specialization corresponds to geodesic flow on the probability simplex. This provides quantified approximation bounds for understanding specialization dynamics. Derive a theoretically justified failure predictor for mode training. This metric, the Fisher Heterogeneity Score, FHS, enables early detection of potential training issues. Introduce the Fisher Specialization Index, FSI, as a principal metric for most specialization. FSI demonstrates high correlation with downstream performance, offering a reliable measure. Up next, our fifth paper out of 5, Discovering Novel LLM Experts via Task Capability Coevolution by Andrew Dai and Yujin Tang from Sakana AI. Let's break down its key contributions. Introduces the Assessment Co-Evolving with Diverse Capabilities, ACDC, framework for open-ended LLM discovery. It enables simultaneous evolution of models and tasks within a single training run. Evolves large language models, LLMs, through a model merging strategy. This allows for the creation of new, potentially more capable models by combining existing ones. Evolves natural language tasks by generating synthetic data. This dynamic task creation ensures a continually challenging and diverse set of problems for LLM development. Leverages the coevolution of LLMs and tasks to discover novel capabilities. This process drives the creation of LLMs with broader expertise without explicit benchmark optimization. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.